Hello guys, welcome back to MedZone African Motives. In this case, we have got a typical exam revision that we are going to consider as part of our revisions as we are preparing for the exams which are ahead of time. So that was for the August 2025 exams. The question paper, which was written on 30 July 2025. So that is the one that you're going to consider for our mathematics end form. So make sure, guys, as an individual, you have all the basics of the topics, okay? Because this is a revision, so we are not going to dwell much. We are going straight to the point as we have done the introductions for these topics, okay? So we have got our instructions. Make sure that you go through each and every part of your instructions, especially your answers to three decimal places unless indicated otherwise. And we are given on question number one. Okay, so that was our question number one, 10 marks, which is on our functions and graphs. We are given on question 1.1, draw a neat graph of the y is equal to log x in base of 2. A logarithmic graph. We had two options to attempt this typical question. Remember, when you are to draw or to sketch a typical graph, what is important are the critical values. The shape of the graph, the critical values, which is the x-intercepts, the y-intercept. If they are turning points, also that must be considered. So on a logarithmic graph, okay, which is y is equal to the logarithm of x in the base of 2, it's a straightforward function as we do understand that the values of x, guys, when we are given a log, remember, okay, let's go back to our logarithms, okay? Let's say I put this one in the base of 2. Okay, let's just start by -1. You see? Nothing. There's no solution there. We do not have log of a negative, right? I want you to see again. Let's go to 0. The same thing. So meaning to say, with that understanding that you have of a logarithmic graph, guys, or a logarithmic function that you are given, we do understand that for the x values, we cannot have anything from 0 going to the negative. There is nothing here. There is nothing. So meaning to say our y-axis in actual sense is an asymptote. It is a limiting line where our graph cannot pass that. It cannot pass the y-axis. So meaning to say we do not have the y-intercept. It cannot reach the y-axis in actual sense. So there is nothing about the y-intercept. So what is important, guys, is what? The x-intercept, which is a condition that happens when y is equal to 0. So if we are to put a 0 there, that's the logarithm of x in the base of 2. 2 to the exponent of 0 must be equal to what? Must be equal to x, which is what? Which is 1. So our x-intercept is supposed to be at what? At 1. Remember the shape of a logarithmic function, just like the graph of what? Of a line. Line is still a log, remember? So you're going to have something like this increasingly for the x values that you're going to have this side. Okay, so that is our graph. Y is equal to the logarithm of x in the base of 2. Straightforward. We can have that graph. Okay, another way that we could have drawn this graph is understanding that a logarithmic graph, it is an exponential graph, guys, at the same time. What am I trying to say? Y is equal to the log of x. If we make x the subject, it becomes an exponential function. Remember the ABC concept. Log A in the base of B is equal to C can be written in exponential form. All right, where our a here is equal to what? Our a is equal to b to the exponent of what? B to the exponent of c. So in our case, this is the same as the logarithm of x in the base of 2 equal to y, so that we can properly see this part. Our a being what? Being x. So x is equal to what? 2 to the exponent of y, b to the exponent of c. So that is 2 to the exponent of y. So as we can see, guys, it is an exponential function. So if you are used to y is equal to a to the exponent of x, to say, okay, for this type of a graph, if I'm having an exponential function, we can have conditions dealing with our a being, considering that it is greater than or equal to 1, and our x is this and that. We have got your sketch in this way, or you can have another one this side, depending with what you're given. It is of y is equal to a to the exponent of x. But have you ever asked yourself, if it is of x is equal to a to the exponent of y, how it is going to look like? This is the typical type of a graph of this nature that we are given, which will be this side. The same as a log that we are having there. So you could have treated this one as an exponential function of x, not y. For y, it is a log. If we are talking about y is equal to, guys, it's a log. But for x, it is an exponential. It is the same thing with parabolas. Remember, you are used to a parabola of y is equal to maybe 2x squared. They can give you a parabola x is equal to 2y squared. You must know the difference. X can be written in terms of y as an exponential function. Same as a parabola again. All right, so without wasting our time, guys, for the critical values, that was the y-intercept, I mean the x-intercept, and also the shape, knowing that the y-intercept is what? Is an asymptote for 2 marks, guys. That was enough. I think you can go through that one. Okay, go through also the basics of how to draw a proper logarithmic graph using points. Okay, draw a neat graph of this. Okay, so what are we given? The first thing is to understand here's the type of the graph that we are given, and it is very, very difficult to note when we are given such a layout. But if you are used to this concept of your graphs, guys, you can relate something here. X, then there's a square root, something there. Which concept can we get here? Remember, when we're dealing with a semicircle, x is equal to plus the square root of r squared minus y squared. Or x is equal to minus the square root of r squared minus y squared. We have something similar to that. We've got something similar to that. Because our x here is on its own, the square root is on its own. And take note, we only have a single sign, a plus. So what can we do? Let us just make the x the subject. As we can see, x must be the subject of the formula. So if we are to take the plus square root to the other side of the equation, the moment we take it, the moment it crosses the equal sign, what happens? It becomes a negative. So it will be like this. It's a negative now. It was a plus, now it's a negative the moment it crosses the equal sign. So this layout, we are used to it. It is here. We are used to that. It is what? The part of our semicircles, remember? So meaning to say, they gave us a semicircle in a hidden manner. They are trying to hide that. So know the format, guys. You know those formats. Each and every format, you must know each format so that you won't be tempted to end up with a circle here. No, this one is a semicircle because of that negative. All right, so we have got a semicircle that we are given. Remember, in this or presentation or the format that we are given here, what we just need is to know the radius from our r squared. So 16 is same as what? 4 squared. So this part could have been written as minus the square root of 4 squared minus y squared, where the 4 represents what? The 4 represents our radius. So our radius of the semicircle is 4 units. Take note, x is equal to minus, it is to the negative of x. Okay, what am I trying to say? What am I trying to say? That's here. This is our x-axis. So this is the positive side, the negative. So I'm saying to the negative of x. If there was a plus, it was going to be positive side of x. If it is y is equal to plus the square root of r squared minus x squared plus 4y to the positive of y on top, a minus to the negative of y below. So this one is for x carrying a negative. So we're going to find it to the negative side of what? To the negative side of x. So that is the condition of a semicircle. So this is our radius, guys. The intercepts from the origin to the y, that is 4 units. Negative 4 as you are going down to the left, negative 4. So that was what we just needed on this semicircle. So we can write this final presentation, or you can write the way that it was written before. X plus the square root of 16 minus y squared is equal to 0. All right. Just like that. So they'll mark there the x-axis, y-axis, the shape. They are checking on those. Are you labeling your axis properly? And also to write the equation of the given graph on your sketch here. You must write down the equation. Make sure you do so. Okay. And also, guys, for you to be able to download this question paper, you can check on the description of the video, or on the comments. You can check, there's a comment that I'm going to put there, which is going to be having an access for you to download the question paper. And also for those who want to join the membership, you can also check that link, which is also there, so that you'll be able to join your membership. Okay, so let's consider another part of our graph, which is 1.21. All right, it's just a continuation here. Is the graph that we have just drawn a function or a relation? All right, a semicircle that we have just drawn, is it a function or a relation? From our vertical line test, we can see that it is going to cross at what? 2 given points. So that is what? A relation from our vertical line test. So this one, it is a relation. Is it continuous or discontinuous? It is a continuous, guys. From this point up to this point, there is no need for you to lift the pencil when you're drawing it, or to lift your pen. No, it is a continuous. Okay, so this one, it is continuous. Okay, so that was it for this part of 1.2. We move on to 1.3. Draw a neat graph of this. All right, so what are we given there? If you check, they're trying to hide a certain graph that we just need to figure out. X plus 4 over y is equal to 0. What is it they're trying to hide here? We are not used to the y in the denominator like this. So let us just get rid of it, because this is same as over 1 over 1. So our LCM, or the LCD, is what? Is y for the given denominators. Multiply each and every term by y there. That was going to give us xy plus 4, which is equal to 0. Having a product here of x and y, guys, this alone tells us something about a rectangular hyperbola. Tells us something, because there is something about xy being equal to what? To the constant k. So can we have xy as the subject of the formula? Yes, it can happen. We just need to take the 4 to the other side of the equation. So therefore, we're going to have xy on one side of the equation. So xy is equal to what? The positive 4 to the other side was going to give us a negative 4. So we have the format here. Our k being a negative, we are given a condition where this constant is a negative on a rectangular hyperbola. We understand we're going to have this in the second and another one in the fourth quadrant, where the x-axis and the y-axis are what? Are simple dots. It cannot pass through those axes. So it's a straightforward graph, guys. It's all about the shape. It's all about the shape. So in this case, we are done, guys. It's all about the sketch. Yes, you can have your points. When x is this, when x is, you substitute, you find the y values. Still, it is going to give you one and the same thing on your presentation. So for a negative value of k, we're gonna have our graph in the second, another one in the what? In the fourth. So like I said, that is what you just need, guys. Okay, in terms of your presentation, so our mathematics N4 tells us that for graphs, what is important is the shape of the graph, the critical values, where they are critical values. All right, so that is it for 2 marks. Just sketch that one. Draw a neat graph of, okay, what is it that we are given here? This is a straight line. Remember, from a straight line, a linear function, the intercept form. There is an intercept form, which we can write x over a plus y over b is equal to 1, where a and b will be our intercepts. The x-intercept, the y-intercept. Straightforward like that, guys. Having your x-intercept and having your y-intercept, you can draw the graph. So what is important here is to just know that what is our x-intercept? Already this is equal to 1. So our x-intercept is the value of x, which is what? Which is 2. So x is equal to 2. Y-intercept, y is equal to what? Y is equal to 3. So those are our intercepts that we are going to need in order for us to draw this graph. We will have these intercepts. You're done. So that is it, guys. For this one, let's say this is 1, 2, 3. Okay, something like this. Let's say I've got 1, 2, and 3. So the x-intercept is what? Is 2. You mark that one in the x-axis. That is our A. And the y value, which represents B, is what? Is 3. Positive 3. So with these two, we can draw our straight line using a ruler. Okay, just join the 2 points. You have got what? A straight line. So that is it, guys. X over 2 plus y over 3 is equal to what? To 1. It was also a straightforward function or graph, as we are to consider the x and y intercept, which are directly given from the format of our equation. Yes, we can use the concept finding x-intercept, y is equal to 0, finding the y-intercept, x is equal to 0. You can do that. It's not a problem. Still, we're going to have same values. On question number 2, we are given 2.1. We must prove, all right? We must prove using the method of what? Determinants, that expanding along the first row and the first column, the answer is what? 72 for the determinant of this. Okay, let's see and prove that our determinant is 72, but we must follow what they said. By what? Expanding the first row. Let's start with that one. Expanding the first row. You follow the instruction. So the first row, that is rows. These are rows. These are columns. All right. So we are dealing with these horizontal lines, those are what? Those are rows. So the first row is this one. So it's first, second, third in that order. Those are rows. So the first row, which is this one. Okay. So with that part expanding along that, we know the signs are going to be what? Plus, minus, plus. Okay. So let's find our determinant, guys. So we're going to have plus what? Plus 2. Okay. So that's plus 2, which is plus does not affect. Then we find the determinant when we close the row and the column where that 2 is. So as we can see, this is going to remain, guys, 1, 5, 1, 2. This is what you're going to have as a 2 by 2. So 1, 5. Okay, sorry for that. This part here is the one that we need. So we're going to remain with 1, 5, 1, 2. We do the same for a minus affecting what? Affecting 4. So that's minus 4. Its determinant when we close the row and column where that 4 is. If we close the row and the column, you're going to remain with what? 3, 5, 6, 2. Those are the ones that we need. All right. So you said you're going to remain with 3, 5, 6, 2. 3, 5, 6, 2. All right. Then we move on to the last part, which is the plus here affecting what? 6. So that's plus 6. Then its determinant when we close the row and column where that 6 is, the one that we are talking about here. What is going to remain? It is this part. That is the one that we need, that 2 by 2, which is what we said we're going to remain with what? 3, 1, 6, 1, like that. So this is what we're going to need. Find the determinant from there. As we do know, guys, all right, and also the issue of marks here, they had 8 marks. So meaning to say one has got 4 marks. So for 4 marks, they can give you 1 mark here. So let's just try the issue of marks because there were a lot of marks there. So if there are a lot of marks, guys, also show almost every step, if it is possible. All right. So here we can say, let's say they give us a 1 here and finding expanding determinants, expanding them again, and final answer. All right, so let me just skip one step because of 4 marks. Okay, so here I'm not gonna show, guys, to say 1 times 2 minus 1 times 5. No, that one I'm just gonna write the final answer. All right, so remember the determinant of a 2 by 2 matrix of A, B, C, D, it is given as AD minus BC. So that's AD minus BC. This is the one that we're gonna need. So here, like I said, I'm not going to indicate that process of multiplying 1 times 2. No, I'm just gonna write the final answer. The stages or the steps are enough for us to have what? The final answers. So this is it. 1 times 2, which is 2 minus what? 5 times 1, which is 5. It was gonna give us what? Negative 3. Just use your calculator, guys. Negative 4 is gonna multiply its answer here. If you multiply 3 times 2, that's 6 minus 5 times 6, which is what? Which is 30. So 6 minus 30 is what? Minus 24 plus 6 is going to multiply its answer. 3 and 1, that's 3 minus 1 times 6, which is 6. 3 minus 6 is what? Negative 3, just like that. Okay, so meaning to say I've got a mark there. It is a mark to get this one. So combining everything, all right, let's just, because we need 4 marks, let's just show the step of expanding 2 and negative 3, negative 6, negative 4 times negative 24, that's positive 96. 6 times negative 3, that's negative 18. Then you can use your calculator to combine everything. That was going to give us what? 72. At least we've got 1, 2, 3, 4. Yeah, they can give us our 4 marks there. Remember, why am I saying 4? Remember, you're supposed to expand the other one. So I divided these two, 8 divided by 2, because there are two things to be done using the same concept. So meaning to say each must carry what? 4 marks. Okay, so that is it. We've got 72, so we managed to prove by expanding the first row. Do the same thing by expanding what? The first column, as they told us there. Do the same thing. Okay, so let's see. Here, we are done with the first row. We move on to the first column. These are columns, like I said, all right? So the first one is this one. This is our first, second, third. Okay, so the first column, those are the numbers that we need. 2, 3, 6. Remember the matrix of sign, guys, plus, minus, plus, in that way. It is the same even going down, plus, minus, plus. Even if you are going down, we use the same concept, plus, minus, plus. Just like that. Same concept. So in terms of the signs, these are the ones that we're going to use. All right, so let's expand, guys. As we can see, it's a straightforward. So the plus affecting what? Affecting 2. So that's plus 2. Our determinant is going to be equal to. So we had got plus 2 there, the determinant, by closing the row and column where that 2 is. The row, the column, so as you can see, we're going to remain with 1, 5, 1, 2. Okay, so those are the numbers that we need. 1, 5, 1, 2. We move on to the second one. The minus is affecting what? The plus 3, the one that is corresponding there. So that is minus 3. Find determinant when we close the row where that 3 is, the row and the what? The column. So if you close the row and the column, they're going to remain with 4, 6, 1, 2. All right. So 4, 6, 1, 2. 4, 6, 1, 2. We move on to the last one, the plus affecting what? 6. So that's plus 6 determinant corresponding if we close the row and the column where that 6 is. We're going to remain with what? 4, 6, 1, 5. Just like that. So let's find our determinant. Just like the previous case, guys, let us just find our answers. The major diagonal minus the minor diagonal on your multiplication, what are we going to have? 1 times 2, that is 2 minus 5 times 1, which is 5. So 2 minus 5 is what? Negative 3. Okay, minus 3 to its answer, 4 times 2, that's 8, minus 6 times 1, which is 6. So that's going to be what? That's going to be 2, plus 6 to its answer here, that's 20, minus 6 times 1, which is 6. That's going to be 14. Yes, positive 14. Okay, then we combine just for the sake of marks, because we need 4 marks here. Let us just expand also here. 2 times 3, 2 times negative 3, that's negative 6. Negative 3 times 2, negative 6. 6 times 14, which is 84. So 1, 2, 3. You can have the final answer. Combine everything, which is what? Which is 72. So as we can see, guys, it has been proven that our answer is going to be 72, even if we are to expand the first column. This is the idea of determinants. The determinant is supposed to be the same. You choose any row of your choice, any column of your choice, you are going to have the same answer, 72. So this one, we are following the instruction. Follow the instruction. They said by doing the first and the first row, first column. 2.2, we are given a question which is on our complex numbers, where we had to express in polar form and represent it on an Argand diagram. All right, so that's our question 2.2 for 4 marks. Given, or we are given this z, which is equal to minus 2 minus 3i. In order for you to have or to present it in polar form, to express it in polar form, also you need the idea of that Argand diagram, guys. Because for the angle, you must tell exactly which quadrant is this complex number going to lie? Where is it going to lie? All right. Our real is negative. Our imaginary is negative. So in this case, we are going to have this one in the third quadrant. Real is negative. Imaginary it's negative. So let's say this is -2. This is -3. It was going to meet here in the what? In the third quadrant. All right. So this is what I'm trying to say, guys. To say if you are to have the final answer, also take this in rectangular form, have it on the Argand diagram, understand what is happening here. This is our -2, the distance in the imaginary -3. So this is the also distance that we have this side, which is what? -3. So inside of this diagram, our triangle, there is an acute angle which is inside of the triangle, which is the reference angle. The acute angle that you find here, let's just call it alpha. It represents the reference angle. Then there is the theta, which is the one that we need in polar form. Remember, in polar form, our z is supposed to be given as r angle of theta or r cis theta. The theta, which is our argument, is the angle that is being taken from the positive real axis. Whether we are going to take it in the anti-clockwise direction to this, or we are going to take it in the clockwise, as long we are moving from the positive real axis. So those are the answers that we are going to expect for the angle. So let's just call theta 1 and this one theta 2. Those are your angles. One of these, they are going to mark those. Those are the angles representing the argument, the one that we need as our theta. Yes, our argument is supposed to be an angle which is in between, like from 0 to 180. But we can also take angles that are greater than that because they are the same. So in your syllabus, they don't mind about that one, okay? So you can use a positive angle or you can use the negative angle. So theta 1 is positive, theta 2 is what? Is negative. Remember the direction. Angles taken in the clockwise are negative. Remember that, okay? Trigonometry. We are back to our trigonometry there. So this is it. So let's first have our r there and theta, then we go back and finalize our answer to the what? To the Argand diagram of the polar form. This is the Argand diagram for what? For the rectangular form. So there is r there, the distance from O to this point. Let's just call it OZ, okay? Which is the hypotenuse, our modulus. So r, remember, it is the square root of a squared plus b squared, or some they use x squared plus y squared. It is one and the same. So that is the square root of these, -2 squared and what? And -3. From Pythagoras theorem, guys. There's no need even for the formula. Just use your Pythagoras theorem. So that's going to be 4 plus 9, which is what? Which is 13. So we have got square root of 13 units. We determine the reference angle, which is our acute angle inside of that triangle, this right angle triangle, so that we can determine the final angle theta. So that's our reference angle, which is what? Which is our alpha. In that case, this one, this alpha. It is equal to what? Arctan of the opposite, as we are given the opposite and the adjacent. So opposite -3 over the adjacent -2, which these signs are not supposed to be used, guys. All right. So just, okay, for the sake of revision, no problem. Even if you get a negative, know that the reference angle, you write it as a positive. All right. So there was no need for that. So arctan of 3 over 2 was going to give us 56,3. 102 3 decimal places, which is just 56,31, okay, which you use now to determine the exact angle. It's either theta 1 or theta 2. So using theta 1, most of you guys are used to the positive angle. Let me just use that one. So theta 1, which is our angle, is going to be what? 180 degrees plus alpha, our reference angle. As you can see, it is a combination of the straight line 180 and this acute angle, which is our reference angle. So you must add from our trig concept, our trigonometry. So that was going to be 180 plus 56,31, 180 degrees plus our alpha, which is our reference angle. All right. So that was going to give us 236,31. If you were to determine theta 2, this theta 2, this one, remember, is the third quadrant, and we're talking about a negative angle. So this is alpha minus 180 degrees. It's a negative angle, so it's supposed to be alpha minus 180 degrees. So I want you to use that. Your alpha is what? The reference angle, this one that you calculated, still is applicable. You can use that one. It's one and the same. Okay, so that is it, guys. So we're gonna have our Argand diagram in a polar form. Remember, this is for the polar form. So whatever z that we're given there, it is r, which is the square root of what? The square root of 13. The angle, which is the one that we got there, is what? 236,31, or you can use this one in the negative. Still, on your presentation, it is going to be in the same quadrant, so there's nothing to worry about that. So this is it. We can have it finally on our Argand diagram. This time, what is important is to indicate what you are given here. Remember, this is the modulus, our hypotenuse. So from the origin, we need square root of 13 units. Then the angle is 236, which is in the what? Which is in the third quadrant here, more than 180 degrees, the way that we had before. So that is it here. This is the angle that we are indicating, 236. So meaning to say, if you had that negative angle, you're going to take it this way. That is how you're going to indicate it. It's one and the same thing, all right, for the negative angle. But here we are talking about the positive angle, 236,31 degrees. Then the distance here is what? The square root of 13 from the origin. That is the square root of what? The square root of 13. So for the polar form, that is what is important for you to indicate. That is what is important. It's a format on its own. So know what is important on that format on your presentation. So you need the angle and the modulus. So that was it for our question. We had to convert to polar form, finding of what? Finding of our modulus and the angle theta, which is our argument, which I said it can be positive. It can also be negative, depending with the one that you want to use. Then 2.3, you are given to simplify this using what? Complex numbers. Okay, let's apply. Let's use our complex numbers to simplify this part. There is a fraction. So for a fraction, what we just need is to make sure that the denominator is a rational number. So we must rationalize, which is multiplying both the numerator and the denominator by what? The complex conjugate of what is in the denominator. So if our z is 4 minus 3i, what is its complex conjugate? You introduce a negative on the imaginary part. So it's going to be 4 plus what? 3i. Negative times negative is what? Plus. So that's the one that we're going to multiply the numerator and what? The denominator by the complex conjugate of this. Complex conjugate. So you're done, guys. Just say expand there, multiply properly. These are two different complex numbers. Expand your brackets properly as you're multiplying the numerators together. So that's 3. It's going to multiply everything in the second bracket. We do the same thing for 2i. Okay, so 3 times 4, that's going to be 12. All right, 3 times 3i here is going to be 3 times 3, that's 9. So that's 9i. Then we are done. We move on to 2i. This 2i is going to do the same thing. It multiplies 4. So that's 8. That's 8i there, then 2i times 3i at the end. So plus and plus is going to be plus 6i squared. All right, remember I, guys, is just like j squared. Okay, the part of j that you're used to. Everything is over what? The denominators, guys, if you are to consider multiplying this to this, we are multiplying z to its complex conjugate. So remember that if you are doing so, our product of z and its complex conjugate is simply a squared plus what? Plus b squared, or if you are using x squared plus what? Y squared, the value of x and the value of y from what you are given. So this is our a, this is our b, this is our a, this is our b. So it's a squared plus b squared. You just square those numbers. So that is what? 4 squared. Our b, which is what? Which is 3. Not minus the number here, here. This one. That is your b. That is your b. So that's plus 3 squared, just like that. Yes, you can expand like this. The way that we did here on top, it is still one and the same. You're going to have same values on your final answer. Okay, so let's combine, simplify the numerator. They are like terms. So far we can see that we've got 8i and what? And 9i there. So let us combine these two. 9 plus 8, that is going to give us what? 17. So you're going to have 17i here. Okay. All right. Let's see what's happening now. That is, all right, guys. Okay. Let's see. Guys, what happened? Okay, no problem. So that's 17 here. And there is the I squared. Okay, remember I squared is just like j squared, -1. So I squared is -1, which is what? 6 times -1. So that was going to give us -6, everything over 16 plus 9, which is what? 25. Or you can just write 16 plus 9, no problem. So with this, we can combine the numerator again, because we have got like terms here, the 6, the 12 and the -6. So 12 minus 6, that's positive 6 plus 17i, everything over 25. The format at the end of the day is important, guys. The format. Z is equal to A plus BI, or maybe it's X plus Y, like that. So to have that, we are supposed to divide so that we see properly what is representing our Z in what? In rectangular form. 6 over what? Over 25, the real term. Then the part of the imaginary, 17 over what? 17 over 25i. So that we can properly see the real term and the imaginary part. So that was it for this one. I think these guys, we here can have a full marks. How many marks were there? Yes, 4 marks. Okay, for 4 marks, they can say 1, 2, 3, 4. Yes. Okay, so it's still fine. Okay, so this is how we can have our final answers at the end. All right, 2.4. Solve for x and y using complex numbers for this given equation. All right, there is an equation which is under our complex numbers. So solving, guys, there can be so many ways to solve these. We can use so many ways, but let us just figure out what we can do. Here there is x and y at the same time, simultaneously. Okay, someone can choose to rationalize here, just like the previous case, where you need to make sure that the denominator is a real term, or someone can choose to get rid of the fractions, which in this case, I see it can be an easier option. All right, because here it's just going to be under a product. So here, rationalizing is fine, but you're gonna find complex conjugate. After that, you multiply again. So just multiply. It's straightforward, guys, isn't it? Okay. But anyways, any way that you feel like is also good. So x here is gonna multiply everything. That's x into 4 plus j is equal to the 2 minus j, and the y minus j is going to multiply each other. So that's y minus j like this times 2 minus j. So this is what we have on our presentation, and we must expand the brackets. We are still far from equating our terms. Remember the issue of complex numbers, we are dealing with the equations where you must equate the part of the real terms. Maybe a given a plus bj is equal to x plus maybe a given yj, like that, where you must equate the x, the y to the. We are still far. We cannot do that because we do not have exactly the real term. We cannot see this is the real term, this is the imaginary. So let's expand our brackets and simplify. Expand and what? And simplify. Okay. So x times 4, that's going to be, as we are distributing the first bracket, that's going to be 4x plus jx or xj. Okay, so we've got 4x plus uh, x times j, which is going to be jx or xj. This is equal to, on the right hand side, there are two brackets. So one is to multiply the other bracket. So we're going to use the first bracket to multiply everything in the second bracket. So that is y times 2, which is what? Which is 2y there. Y times minus j, that is minus jy, like that, or you can have as minus yj, whatever that starts. It's up to you guys. We are done with the part of y. We move on to the minus j. So the minus j is going to multiply 2. So minus j times 2 is going to be minus j2 or minus 2j. Okay, the minus j multiplies the minus j at the end. So minus times minus, that's a positive. J times j is what? Is j squared. So we can collect the like terms if they are like terms, or anything that we can simplify. But as for now, you can see that's a little bit difficult. So let us just rewrite and simplify the right hand side. That is, there is a j. So this one, it's all on a j. This one is under a j. So let's try to put it together. J squared is what? Is minus 1, remember? So it's gonna be 2y minus 1, j squared. So I'm taking these two together. Why? We do not have j there. We do not have that j. So it becomes the real term. So that's our real term, this one. We need to have the same format as this one, where there is plus jx plus j plus j. So what are we going to do? We can factor out a plus j from these two where there is a j. So if we factor out, we need the same format. Don't confuse yourself. Say there's a plus there, there's a minus, for especially for these brackets that you have there. Yes, you can factor out a minus as long you understand how to analyze it at the end. So here I want to avoid that confusion. So I'm just going to factor out plus j plus. I want to see this plus j. I want to see that plus. So if I factor out plus j here, remember guys, a plus does not affect. So you're going to remain with a negative. So it's going to be negative y like this. Negative j y over plus j. So this is going to cancel. You remain with what? With minus y. Negative j2 over plus j. This is going to cancel. So you remain with what? Minus 2. This is what I'm trying to say, guys. Okay, you factor it out from here. So now that we have simplified the right hand side in the same format as the left hand side, We can equate now we can use this condition, equating the real terms together, the x to a. Those are real terms where we do not have j. There we can equate the 4x and what? The 2y minus 1. Those are real terms. We do not have a j here on this one, on the left hand side. On the right hand side, on this whole part of 2y minus 1 here, there is no j here. There is no j. We do not see it. Those are real terms. They are the same. So we can form an equation to say 4x must be exactly equal to this. It must be exactly equal to that. 2y minus 1. It is an equation that we have formed. It is an equation that we have formed. Yes, you can choose to rewrite 4x. You take the 2y to the other side. Minus 2y is equal to minus 1. Guys, rewriting, simplifying, there is another thing. It's another thing. You can leave it as it is, as it is. There, it's an equation. If that you have formed here as it is, you can leave it. It is an equation that you have formed. You can leave it like that. Rewriting, it is in your hands, the way that you understand. Okay, let's see. The next part, the J part. The J part, remember the E is what? Plus J. Plus J. So what does it mean? What is remaining is exactly equal, which is what? The x is exactly equal to this. So you equate that one. X must be exactly equal to minus y minus 2. That's another equation that you have formed. Just like that. As long you can see the real on its own, the imaginary on its own, you are done, guys. Form equations. After that, solving, it's in your hands. You can use those elimination, substitution, it's in your hands. In this case, substitution can be easier because I can see on equation 2, x is already what? The subject of the formula here. X is already the subject of the formula. X is equivalent to this. So in place of x in equation 1, I can substitute with this using what? Substitution method. So using substitution method, let us substitute. We're going to substitute equation 2 into what? Into equation 1. That's x of equation 2, this one. We put it in equation 1 in place of x. So that is 4 into x. Our x is what? This minus y minus 2. Just like that, which is equal to what? 2y minus 1. Let's solve for y. As we can see, there is only y here, so we can distribute 4 times negative. That's negative 4y. 4 times negative, that's negative 8, equal to 2y minus 1. We can collect the like terms. The 2y to the other side is going to be negative there. So 4y minus 2y is equal to the minus 8 to the other side is going to be a positive. So it's negative 1 plus what? Negative 1 plus 8. Is it necessary, guys, for me to show this? No problem. Let me just finish up. We are almost done. Dividing by negative 6 by negative 6. So y is equal to 7 over minus 6. So just write the negative in the numerator. Okay, so that was our y value. Negative 7 over 6. With this y value, guys, I can simply substitute back. Remember, we are using substitution method. So we can just substitute back into equation 2 because there x is already the subject of the formula. So thus we can determine the value of x from there, from equation what? From equation 2. X is equal to minus y. What is the value of y? Minus 7 over 6. We substitute the value of y there, minus 7 over 6. After that, we must subtract a 2. So our x was going to be negative to negative. That's 7 over 6 minus 2, which was going to give us a negative 5 over 6. So that was the x value. So we've got the x value. We also have the y value. So that is to solve complex numbers. You must have two complex numbers in rectangular form, one on the left and the other one on the right, as we had these two in rectangular form. Then we can equate the real terms together, the imaginary terms together. So for 4 marks, okay, complex numbers, mostly they are like that. They do not give those marks that we expect to say. If it is like this, supposed to expect 8 marks or something. No, 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 they don't do that. So you just have to be careful also what you expect in exam and how they give the marks. So on question number 3, we had 3.1, determine the value of x. That is our part of our trig equations. We have an equation for the values of x to be taken from 0 to 360 degrees. Okay? It's if we are to consider this equation, we can see something that is not familiar to some of the equations that we had before in terms of the question papers. But there is another question paper that had something like this. But for the introduction questions on those videos, guys, I did similar questions of this nature. If you still remember when we talked about grouping, because there are 4 terms. 1, it's a single term. 2, it's a single term. 3, it's a single term. 4. So we are supposed to try by all means to factorize by grouping. So I'm going to take the left hand side to the right hand side. So it's, the right hand side to the left. So it's going to be -4, the cos of x. The positive 6x to the left hand side is going to be -6, the sine of x. So meaning to say, on the right hand side, we are left with nothing. That's what? That's a 0 there. We took all the terms to the what? To the left hand side. Having our 4 terms, as I mentioned before, 1, 2, 3, 4. We must figure out factorization by grouping. Given 4 terms, factorization by grouping. Okay? So we can group these into 2. Our 4 terms that we are given there, we try to group them into 2 and see if there is something common for those 2 terms. Is there anything common? So for the first 2 terms, we can see the sine of x is common, and thus we're going to remain with the sine. There we're going to remain with cos. The same thing here, we're going to remain with the sine and cos. Okay, so guys, here seems that we have got something common for the 2 terms. The first 2 terms, we're going to factor out the sine of x, right? So let me just write equal to, no problem. So that's the sine of x into what? We divide. So 3 sine squared divided by the sine of x, we're going to have sine of x. Okay, there's 3 there. There is a 3. 3 sine of x. 2 sine of x cos x. So this and this was going to cancel. So you remain with what? 2 cos x. All right, so that's plus 2 cos of x. So what is it that we need for the last 2 terms? We must factor out the highest common factor as usual, but we must consider that these brackets must be common. The bracket that you're going to have here is supposed to be the same as this one. So take note there, especially on the sign. It's positive inside. There is a negative, there is a negative. So we must factor it out so that we obtain what? Positive values. Then, is there anything common between 4 and 6? 2 is the highest common factor. 4 is 2 times 2. 6 is 2 times 3. So you can see that 2 is what is common. Okay, between cos and sine, there's nothing common. So let's factor out. -4 divided by -2, that's +2. Cos of x. negative 6 divided by negative 2, that's positive 3, the sine of x, which is equal to 0. So someone is asking now to say, are these two brackets the same? Are they the same? Guys, a plus b is the same as what? B plus a. So here we've got same thing. They are all positive. Look, 2 cos x, 2 cos x. 3 sin x, 3 sin x. So they are exactly the same. So we can factor out that common bracket. You factor it out. So I'm just going to take the first presentation. 3 sine of x plus 2 cos of x. Guys, it is the same thing as taking this. It's just one and the same. There's nothing different. So when we factor out this common bracket, we are going to remain with what here? With the sine of x. Here we are going to remain with minus 2 in another bracket. So that's equal to 0. So that is it, guys. We can solve using the zero concept. Remember, from our algebra, two brackets being equal to 0, or the product of two terms to be equal to 0. One of these is supposed to be equal to 0. So this must be equal to 0. This must be equal to 0. That's it. 3 sine of x plus 2 cos of x must be equal to 0, or this bracket where we've got the sine of x minus 2 must also be equal to 0. So if you check, guys, the right hand side, there's nothing that you're going to get here, because look, the sine of x, if you equate it to 2, we cannot have a solution there. Remember, the sine of x from our trigonometry, guys, I told you that the sine of x is supposed to be a value when you simplify. When you are looking into its presentation, it is supposed to be a value that is less than or equal to 1. Being greater than or equal to 0, but less than or equal to 1. So the sine of x is supposed to be equal to decimal values 0, 1, 0, 2, whatever that you have, up to 1, not greater than 1. Once it exceeds 1, there is no solution. But anyways, knowing this or not knowing still is not important, because you can even use your calculator. Arc sine of what? That is shift sine 2, arc sine of 2. You can see that the calculator cannot simplify that. There is no solution on this part. It's not applicable. So we are going to focus with this side and see if there is a solution there. All right, so that is the one that I'm going to take and work it here. So we are left with 3 sine of x plus 2 cos of x, which is equal to 0. Let's try to solve using our understanding of our trig identities and ratio. Where there is a sine and a cos, we do understand that tan of x can be formed from the division sine x over the cos of x. Can we achieve that? Because these are two single terms. There are two single terms. So someone can say, okay, since I want to have sine over cos, let me take this to the other side. So it's going to be 3 sine of x is equal to negative. The moment it crosses the equal sign, it changes the sign. All right. So to obtain sine over cos, we must divide by cos so that it will be in the denominator here. So divide by that cosine of x. Cosine of x, this can cancel. So sine over cos, this is what you need. Sine of x over the cos of x, which gives you a tan. So it means we have got 3 tan of x. This one, it is representing tan. So that's 3 tan of x equal to negative 2. So that's it. We can see that a tan is there. So we can simply divide by 3 to get rid of that 3 in the on the left hand side. So the tan of x is equal to negative 2 over 3. What we need when solving trigonometric equations is to have the sine of x, the cos of x, or the tan of x. Those are the three that you must use so that you consider the cast diagram or those reference angle concept. You must have this. Just like the first one where we had the sine of x equal to 2, but only that the number here that we are having cannot give us a solution. Otherwise, if it was something like sine x is equal to 0.5, we could have been looking into that. You can have that in another question paper or the exam that you're going to write. Therefore, work with that one. Solve again. But in our case, we cannot simplify sine x being equal to 2. So we work with the other part of our equation, which ended up giving us a tan of x as a single trig that you're given. So what is the concept here? It is to find the reference angle so that we can test and see according to the cast diagram. We do understand that our tan, for it to be negative as we are given here, it must be in the second and in the fourth quadrant where there is sine and what? Where there is sine and cos. So we need the reference angle first. Each and every quadrant, remember guys, I told you there is what? A reference angle there, a reference angle in each and every quadrant. So what is that reference angle? It is simply arctan of the number given as the magnitude. You just consider its magnitude, 2/3. Don't worry about that negative, guys. The negative is simply telling us. This is the one for the quadrants now, that negative. Telling us to say which quadrant is it where tan is what? Where tan is negative. Where tan is negative. So let's find this. Arctan. So that's shift tan 2/3. This was going to give us 33.69. We can round off to 3 decimal places. You can see it's going to be a 0 there. Shift, fix this one, 33.69. Okay. Okay. So that is what you're going to have as the reference angle. You can use the general solutions, but guys, let me answer you this part. You are dealing with equations here, trigonometric equations. So what matters is the interval. What matters is the interval that you're given here from 0 to 360. If they write something like minus 360 to positive 360, or it's maybe they are negative angles, or they give us an interval greater than 360 from 0 maybe to 720. They are giving us negative values from minus 360 to 360, or they are actually telling you to say, find the general solution. That's where the general solution can be used on these intervals that are outside 0 to 360. Why am I saying so? The 0 to 360 interval that we are given there, it is the one that we are seeing on our quadrants here from 0 back to 360. Guys, it is the one that we are seeing there. As we consider our quadrants, this will be our 0, guys. We start here from 0 here. That is our 0 point. 2, 360. You are back to 360 degrees. So it is meant for all solutions in within that interval. As long it is in within this interval, guys, you can use the quadrants and all solutions will be there. You are guaranteed that all your solutions are there. But if they give you an interval from minus 360 to 360, or maybe it is more than that, 720, this one is limited in terms of our understanding because it takes from 0 to 360, unless you now apply your understanding to say you have completed 360, you are now taking another revolution, or maybe you are now relating them to the negative angles. In that case, if you understand that, you can use that concept. Or use the general solutions. So in our case, guys, quadrants were very okay to use. So let me just take where the tan is what? Negative, like I mentioned, the second and the fourth, where in the second, our final answer x is 180 degrees minus the reference angle, remember? And here our x is going to be 360 degrees minus the reference angle. If it was in the first quadrant, your x is equal to the reference angle. Third quadrant, your x is equal to 180 plus the reference angle must be added. It's included as part of our solution. So in our case, this is what we need, all right? So the first solution representing x from the second quadrant is going to be 180 degrees minus our reference angle. This is our reference angle, which is 33.69. So that's 33.69. So that was going to give us 146.31 degrees. Okay, or we can have it in the what? In the fourth quadrant. So in the fourth quadrant, which was going to be our x is 360 degrees minus the reference angle, 33.69 degrees. So that was going to give us the value of x, which is 326.31. For these solutions in within 0 to 360 degrees, we are guaranteed that these are the only solutions that we must expect. These are the only solutions, all right? So those are the values of x, guys, that you're going to have, even if you're to use the general solutions, like I said, okay? So that is it. That is it, just like that. So know the steps, know the steps. Without the reference angle, guys, it will be difficult for you to find the solutions. So you must have the reference angle. As you can see, is it arc tan? Is it arc of sine, arc of cos? Where there is no solution, it means there is not applicable. Leave it and solve for the other one. Then 3.2, we are given there a tan of x. All right, let's see. And they are saying it's an acute. X is an acute. The tan of x is equal to 5 over 12, where x is what? Where x is acute, okay? So determine cos x without using a calculator. Cos of 2x, I mean, cos of 2x. Cos of 2x, 2x, take note, the x, but it's what? 2x. So we must be very careful on our presentation. 2x. There it is x. It is something that is slightly mistaken by a lot of people there, because they can give you something like tan 2x is equal to 5 over 12. Then they ask you to calculate cos 2x. You just use the 2x as it is. That is the angle that you're given there. But in our case, the tan of x must correspond to the sine of x. Cos of x. We must have this. Not 2x. So meaning to say we must get rid of that 2 on our cos. From where? Let us consider our identities. This is a double angle identity for a cos. And we do understand that there are 3 identities that you can have from the cos of 2x. Remember I talked about this. Cos squared minus the sine squared. Or it can be 2 cos squared x minus 1. Or it can be 1 minus 2 sine squared x. There is the part of cos of x, sine of x, cos. Oh, this is what we need. Sine of x or cos of x. This is what we need. So we had to rewrite in this. Then we can choose any one of these, because, guys, where tan of x is, you can find sine x, you can find cos x. So you can use any one of these 3. Anyone is up, anyone that you want. So let's focus on finding either one of these 2. We are told that this is an acute angle, so definitely It is found in the what? In the first quadrant as we consider positive angles, the way that we take our angles, guys. So this is in the first quadrant, and there is what? There is x as our angle. So the tan of x, remember from our SOHCAHTOA concept, SOHCAHTOA, that's opposite over what? Opposite over adjacent. So this is our opposite, this is our adjacent. So opposite is 5, adjacent is 12. Use your Pythagoras theorem to find the hypotenuse, which is, we can just call it r in that case. So hypotenuse is the square root of x squared plus y squared, which is the square root. Our x value, that's 12. Our y value, that is what? That is 5. So that was going to give us 13 at the end from square root of 169. So this is 13. So this is what I'm trying to say. As you have the completed right angled triangle with all the dimensions, length that you're given there, we can determine either of these, the sine or the cos, from this diagram. And you choose which of these to use. Because the sine of x can be determined opposite over hypotenuse. Opposite over hypotenuse, 5 over 12. The cos of x can also be determined adjacent over the hypotenuse, 12 over what? Over 13. So having these, it means any one of these identities can be used. Anyone. Anyone, it's a choice. Okay, so that was it, guys. Meaning to say, let's say you choose to use the first one. Okay, let's just use the first one and see. Cos of 2x must be equal to cos squared x minus the sine squared of x. Remember, our question is to answer cos 2x. So the cos of x, we have it, 12 over 13. So that's 12 over 13 squared. Minus the sine of x, we have it 5 over 12, but it must be squared. So that's it. We can have a solution from there. So let's see, what are we having here? Okay, let me just take my calculator back to the normal mode. So we are given a fraction 12 over 13. All right, you square it, minus 5 over 12, then you must square it as well. Okay, so this was going to give us, all right, it's giving us as a decimal. Why not just give me a fraction? I mean, a fraction here. All right, you just needed a fraction. Or let me do this, 12. Okay, let me do this. 12 over what? Over 13. Okay, we square it. This is 144 over what? 169 minus 25 over 144. Then we can subtract this one minus what? 25 over what? 144. Okay, why is it still giving us a fraction, guys? Or maybe it's my display of my calculator, no problem. But I wanted us to have a fraction. It was supposed to give us a fraction of 119 over 169 there. All right. So still giving us a decimal. Okay, let's see on our values here. Cos, okay, that is adjacent. Okay, 12 over 13, which is fine here. And this one, 5. Okay, here, guys, here it's 5 over what? Opposite over hypotenuse, sine. Guys, you see this thing of rushing again. This thing of rushing again. Here it's what? 5 over 13, because it's supposed to correspond. That's another thing. If you're in exam, guys, and you know what you're doing, then you must figure out to say what exactly is happening, because I'm supposed to have a fraction, but it's not giving me the fraction. So what happened? You trace your work back. So this means it was going to be what? 25 over 169. Okay, so let's see. 144 over what? 169 minus what? 25 over 169. So this can happen, okay? We have the fraction that we need here. So this is 119 over 169. So if you check, it must be the same even if we used any one of these, okay? So let's just even consider here there is 2 cos squared. Let's just take that one and see. 2 cos squared. Remember, cos 2 of x is the same as 2 cos squared of x minus 1. So we can substitute the cos of x, 12 over 13 squared. There's a squared here. Okay, whatever that you have there, you subtract a 1. Okay, let me just use the calculator, guys, in case that if there is something, we're not going to waste our time. Right, 12 over 13 squared minus 1. All right, 12 over 18 squared minus 1. Okay, so that's it, 119 over 169. So that's it. As you can see, same answer. So it means even for the last one, the 1 minus 2 sine squared of x, you must have the same thing, 1 minus 2 sine. Let's take this one correctly, 5 over 13. So that's it, 5 over 13 squared. Okay, let's see. Let's see our calculator. 1 minus 2 into 5 over 13, then we must square it. So as we can see, that's one and the same. So you choose, guys, any one of those three. You must have the same answer. You must have the same answer on your presentation. So that was it on this question. Let's see another part. So you must be very careful, guys. You see, those are some of the errors that you can actually have in exam. You take this one, then this one happens. It can't be like that, guys. You know, you are human after all. So let's consider another part. It was to prove. All right. So here it is supposed to be 1 over tan minus 1 over sine on the right hand side. For how many marks? 5 marks. Okay, let's figure out. This is 1, this is 1. So I'm going to take the left hand side of our equation. On the left hand side, there is this whole part, cos squared of theta minus the cos of theta minus the sine squared of theta, everything over 2 sine of theta, cos of theta plus the sine of theta. It must give us exactly what is on the right hand side. Okay, looking into the numerator, there is cos squared, there is sine squared, which is going to make our factorization very difficult to consider. Our factorization is going to be very difficult to consider. But if we see, if we look into this, there is a cos, there is a cos, and this one is a sine on its own. So can we rewrite it in terms of a cos? Is it possible? Remember your Pythagorean identity. Cos squared theta plus the sine squared of theta must be equal to 1. So the sine squared here can be the subject if we take the cos to the other side of the equation. So that's 1 minus what? Cos squared of theta. In place of a sine squared, I can rewrite it as what? 1 minus cos squared. So it means it was going to be cos squared of theta minus the cos of theta minus what are we going to subtract? We are going to subtract what is equivalent to the sine squared of theta, which is 1 minus cos squared theta. So this is what you're going to have here. The denominator, Sine of theta is common, so there I do not need to waste time, just factor it out. The sine of theta, sine 2, sine theta cos, divide to this, you're going to have 2 cos of theta there, plus sine and sine cancels, you get positive 1. So definitely, if you check here, there is something that has to give us the same bracket, or maybe it is the same sine of theta. We do not know. So let's figure it out. In the numerator, since we have a cos and a cos, why can't we just expand our brackets, then simplify by collecting the like terms? It's going to be cos squared theta minus cos of theta. So negative times 1 is going to be negative 1. Negative times negative is going to be positive cos squared of theta over the denominator, as it is the sine of theta. 2 sine, 2 cos, sorry. That's 2 cos of theta plus 1. These are like terms, cos squared and cos squared. So you can add them together. Cos squared added to another cos squared. They are like terms. So it's simply 1 plus 1, which was going to give us what? 2 cos squared of theta. So 2 cos squared of theta minus the cos of theta minus what? Minus 1. Everything over the sine of theta into 2 cos theta plus 1. The numerator, it is a trinomial from our algebra concept there. Remember those quadratic expressions from your factorization. So for us to understand, we can just say, let the cos of theta be equal to x. So it's going to be 2x squared minus x. Cos theta represents what? X, remember. So it's minus x minus 1. How do you factorize this? Okay, there are so many ways. You can even check grade 8. Oh, no, grade 9. Grade 9, grade 10. Yeah, there's a factorization cheat method, whatever way, guys, that you understand. Okay, I can take this 2 to multiply to the constant. That is, get rid of that. So it's going to be x squared minus x. 2 times negative 1, if we multiply by 2, it's going to give us negative 2. Then we factorize, as we are having the coefficient of x squared as 1. We can simply have our brackets x and x. Remember, this one is easier. You consider minus 2. What are the products of minus 2, which adds up to negative 1? Negative 2 and 1, 2 and negative 1. If we add negative 1, it's going to be on these two, negative 2 plus 1. Okay, so what are we going to do? Remember, we removed the 2, so we bring it back where there is x. We're going to bring back the 2. Where there is x, we bring back the 2. Then you factorize each bracket you look into the factors for each bracket. If there are any factors, factor it out. The first bracket, 2 is common, so I can factor out the 2, and I'm going to remain with x minus 1. Second bracket, nothing is common, so it's 2x plus 1. So guys, get rid of that 2. It is the 2 that you are multiplying there. It is the 2 that, so it is not part of your answer. This is your answer. So it means here, factorizing this, it was going to give us x minus 1, where x represents what? Cos theta. Cos theta. So that's cos theta minus 1. Another bracket, 2 cos theta plus 1. So this is what you're going to have, of which factorization you can even look into the question and factorize. If you know your factorization, guys, anyway, there I cannot limit you to say use this way or what. The final answer is what is important. After factorizing, you must have these 2 brackets, okay? Now that we have got these, in a factorized manner, we can divide, cancel up, or whatever that you have, which is common between the numerator and the denominator. So these 2, they can what? Cancel out. So we are going to be left with the cos theta minus 1. In the numerator, you'll be left with what? the cos of theta minus 1 over what? The sine of theta. Remember our proof. We must have 1 over what? 1 over tan minus 1 over sine. So here we can see that there are two terms under a subtraction. With a subtraction, we are subtracting these two terms in the numerator. So we can divide each and every term by a cos. All right. We can divide by what? By a sine, not a cos. We have that one in the denominator. So cos theta over what? The sine of theta minus 1 over what? The sine of theta. This one is part of our solution. What about this one? We can see it is not the one that we have on our solution there. It is supposed to be 1 over. But we know that cos over sine represents what? Represents cot. It is cot of theta. That is what we know. Okay, remember this one is fine, so we're not going to change anything. What about the cot of theta? Cot of theta is the same as 1 over what? 1 over tan of theta, remember. So where I have got this cot, I can write it as what? 1 over tan of theta. Is it the same as what I'm given on the right hand side? It is exactly the same that we're being given to prove. So we have exactly what the right hand side is representing. So that is it. That is it. That is the idea, guys. Prove. They simplified it for you. You have the answer there. The answer is there. So they're just saying simplify this. Only that you must have your answer in this manner or in this format. So those are the steps that we could have taken in order for us to show that the left-hand side is indeed equal to the right-hand side. Then 3.4, derive the formula for this 1 over sec of 2 theta. But your answer is supposed to be in terms of sine theta only. We must have sine of theta only on our answer. So what can we do? 1 over sec of 2 theta. 1 over sec, guys, remember it's cos. We know that 1 over cos theta is sec of theta. So if it is 1 over sec of 2 theta, it simply means you're going to have cos of 2 theta. Guys, there is an identity for cos 2 theta in terms of theta only, in terms of sine theta only. Remember that the one that we're talking about, guys, to say cos 2x. So it is the same if it is cos 2 theta. There is cos squared theta minus sine squared of theta. There is 2 cos squared theta minus 1. There is 1 minus what? 2 sine squared of theta. They are just saying your answer is supposed to be this one. There's in terms of sine theta only. This is the answer that you must get. Remember, those are the 3 identities that we've been writing. But here we must derive, we must show, we must simplify up to that. That is the case now. So meaning to say, you do not just write the answer to say, I know cos 2 theta. Those are already derived identities. So your duty is to look for another identity. There's no way. It's trigonometry. You prove one identity from another identity. So let's figure out from our identities the one that we can use, where we have got the cos of 2 theta. 2 theta simply means we added theta plus theta. It gives us 2 theta. So we can rewrite this as the cos of theta plus theta. From which identity? Remember, from our compound angle identities, the cos of A plus B is supposed to give us the cos of A times the cos of B minus, we put a minus, then it will be sine of the same, sine of A, sine of B. So this is our A, this is our B, guys. It is the same thing. So cos theta, cos B, our B is also theta, so it's cos theta again, minus sine times sine, that is the sine of theta times the sine of theta. If we can expand this, we can see that it is gonna give us cos squared minus sine squared. We are almost there. Minus sine squared of theta. Already, we have proved the first one to say cos 2 theta is the same as cos squared minus sine squared theta. We have proved the first one, this one. We have proved it in actual sense, if you check properly there. But ours, it is not about that. It is to show sine theta only. So get rid of what? The cos, because what we need is the sine on our answer, the sine of theta. So meaning to say, we must find another identity which has cos squared, so that we put what is equivalent to that cos squared. You do not just say, okay, I do not need this, so let me cancel. No. You must put what is equivalent to that. From our Pythagorean identity, cos squared plus sine squared gives us a 1. So what about cos squared theta? It is equal to what? Take the sine to the other side. 1 minus the sine squared of theta. This is what represents the cos squared of theta, which is 1 minus sine squared of theta. Minus what? Which we are already given, minus sine squared of theta. There is a sign. There is a sign. That is the only part that we have. So we can simplify this. Minus 1 minus 1, that's what? That's minus 2. So it's going to be minus 2 sine squared of theta. As they are like terms, we can combine them. They are like terms, remember? So it's going to be 1 minus 2 sine squared theta, which is exactly what we want in terms of what? Sine theta only. It's like in terms of x, we are not supposed to have y, we are not supposed to have any other letter, so we are not supposed to have any other trig, cos, tan. No, we just need sine. It can be sine squared, it can be sine to the exponent of 4, as long there is only a sign there, it's fine. As long we see a sign on our answer only. So that was it, guys. It's just proving these identities. They are asking us to prove identities. The identities that you're just given, that you know, they can ask you to derive them. You derive one identity from another. From another. You use another identity to prove another. So that is the concept, guys, that you're going to use to prove any other identities that you'll be given in your exams. All right, 3.4, marking 20 marks for the question 3. Then question number 4, part of our derivatives. Given this for 8 marks, they wanted us to calculate using differentiation the coordinates of the turning points as well as the points of inflection. So here is, it is just turning points. There is no need for us to distinguish anything. Answer the question. All right, you are not to distinguish anything, guys. So that is it for 8 marks. This one was going to be easier. We're not going to distinguish anything. So we are given f of x as what? 4x cubed minus 16x. Remember, for the turning points, the first derivative with respect to x must be equal to 0. So let us determine that. Drop the exponent, we subtract 1. So that's 12x squared minus 16, okay? That is supposed to be equal to 0. That's our f of x, remember. So equate to 0. Then we can solve for x as we are given a quadratic equation. Let's solve for x. 12x squared is equal to 16. To the other side, the minus 16 is going to be positive. So simply divide by 12 by 12. That's x squared is equal to 16 over 12. What about x? Square root both sides. We are going to have the value of x as what? Plus or minus. So that's it. Square root of a fraction 16 over 12. So that was going to give us, 1 comma 1. Let me just fix my calculator, guys, to 3 decimal places for all the answers. 1,155. So that is it. Plus or minus, we are talking about the square root of what? Square root of a number. So you substitute these, all right? You substitute back properly, guys, in place of what? In place of x into the original equation, y is equal to 4x cubed minus 16x. So I want you to substitute this. You are going to have your turning points, all right? So the first turning point, when x is 1,115 as a positive. So 1,155. So what is the value of y? You substitute your x. Please do it and show that calculation. But as for me, guys, I'm just gonna do this way. 1,155. I store this one at a. Then I'm just gonna have my equation as 4 into recall a to the exponent of 3. Okay, minus 16 times recall a. So that is going to give us minus 12,317 to 3 decimal places. Okay, so we have got the first turning point. You do the same thing, guys. Substitute properly the value of x this time, which is what? Negative 1,55. When x is negative 1,155. So that was going to give us the value of y. So you do the same. I'm just going to store that one first. Negative 1,155. So I'm going to store it back to a. Okay, what did I do here? Store to what? To a. Okay, so I go back on top. This is our expression where a is in our answer. So let me just substitute. So it's going to be what? 12,317. Just like that. So these are the turning points. No need to distinguish anything here, guys. The question is just the turning points. So find your first derivative, equate to 0. Then you find your x values by solving the given equation, substitute properly into the original equation. Then for the points of inflection or the point of inflection, we know that the second derivative must be equal to 0. All right, so let's consider point of inflection. Okay, so the second derivative of x must be equal to 0. Remember, this is our first derivative, which is 12x squared minus 16. So let's differentiate again. Drop the exponent, subtract 1. So that's 24x. This one is a constant, so it's going to give us a 0. So that's it. This is our second derivative, and it must be equal to 0. So 24x must be equal to 0. Divide by 24 by 24. So therefore, x is equal to 0. You do the same, guys. You substitute this x into the original equation as it is. In place of x, you substitute a 0 there. So y was going to give you a 0 if you substitute properly. So that's giving us a point. So our point of inflection is when x is 0. At that point, y is also 0. So that is it for the given graph or function that we have got there. So answer the question, guys. No need for you to tell us about these turning points. Is it maximum? Is it minimum? No, you are not asked about that. Just the turning points and what? The point of inflection. You are done. Then 4.2, expand up to 4 terms for 5 marks. All right, let's expand this. Remember our binomial expansion, 2x plus 4 raised to the exponent of 1 over 2. So I explained another way, guys, which is easier to understand. Yes, you understand, you have it, x plus h to the exponent of n is going to give us x to the exponent of n plus n, this and that, times h plus n times n minus 1 x to the exponent of n minus 2 h squared over what? Over 2. You had this over 2 factorial and so on and so on and so on. Okay, but I explained the derivative concept to say the first term as it is, these are the two terms, the 2x and the 4, okay? Plus, remember there's a plus there. So you take the first term, raise it to the exponent of a half. Okay, this is what I'm trying to say. You understand me very soon. 2x to the exponent of a half. Okay? 4, at that moment, it was there, but it was raised to the exponent of 0, that one. Because these two must add up to the exponent that you're given, which is a half. So if this is to the exponent of half, that one must be to 1. So it was there, but they don't indicate it. Then the next part, the part where the exponent, the first term raised to the exponent, the one that is raised to our exponent here, is the one that you focus with. You differentiate the exponent. You do like this, guys. You remember the concept of a derivative from the power concept. X to the exponent of n, you drop the exponent, then you subtract 1. You do that concept only focusing on the exponent. So this is what I'm trying to say. You drop the exponent, you subtract 1 on the exponent, on that part where x is, the one that is an exponent. So if we drop our exponent, that's a half. Then what is that we do? We subtract 1 on our exponent. So that's half minus 1, which is minus half. So you do as if you are differentiating. It is the concept that you're going to use throughout for that part that you're given that exponent in the first place. What about this 4? It started with a 0, so it will be increasing its exponent. 1, 2, 3, and so on. From 0, it is now 4 to the exponent of 1. Just like that. We move on to the other term. So this is our first term, second term. The third one, you do the same thing, derivative, drop the exponent, subtract 1. So it's a half times you drop the exponent. So it's minus half. Then what is it that we do? We subtract 1 on our exponent. So it's going to be minus 3 over 2. The part of 4 is increasing its powers. 0, 1, now it's what? It's 2. So that is 4 to the exponent of 2, which is the one that we're going to use 2 factorial. 1, guys, there was no need for us to write 1 factorial. Some they want to write that 1 factorial. Okay, some they want to write to say the exponent of 1, so it's going to be 1 factorial. Now this one is to the exponent of 2. So we're going to have this one as 2 factorial. So, okay, no, it's fine. For these ones, guys, I just hope it's there clear. All right. Most of you guys, you're confused on this one, the derivative concept. You just focus on the exponent. Drop exponent, subtract 1. Drop exponent, subtract 1. So where we are here, we're going to drop the exponent. Here, we subtract 1. So meaning to say these ones are just going to remain as it is. 1 over 2 times minus 1 over 2. We drop our exponent there. So it's going to be minus 3 over 2. We subtract 1 on our exponent. So minus 3 over 2 minus 1 is going to be what? Minus 5 over 2. The 4 is increasing its power. So it's now to the exponent of 3. From 2, now it's 3 over what? 3 factorial, the exponent, which is on what? On 4. So as we can see, there are 4 terms right now, isn't it? Because this is the third one, and this is the fourth one. So that's what you're going to have, and so on and so on. So we can simplify, okay, and your answers must be given as positive, all right? You must have your answers as positive. They are not going to write it here, but your answers are supposed to be positive exponents, so you avoid these negative exponents that we are seeing here. All right, so let's simplify the first one. Okay, the first one, we were going to have 2x to the exponent of a half. Remember, to the exponent of a half means the square root of. So it's going to be square root of 2x. Okay, so you just ignore the part of what? 2x for now. That part of 2x, ignore it. Simplify the rest. So this is what I'm trying to say on the second part. Here, we're gonna simplify the rest. So it's 1 over 2 times a 4. You can just use your calculator, guys. 1 over 2 times a 4, that's 2. So it was gonna be 2. As we can see, it's a negative. The 2x is raised to the exponent of a negative. So it was going to be 2 over 2x to the exponent of a half. Since it is carrying a negative, you take it to the what? To the denominator. Okay? So later on, we can have our final answer as what? That's going to be plus 2 over what? Remember, to the exponent of a half is the square root. So you're going to have square root of 2x. We must have our answers in simplest form. No fractional exponents. X to the exponent of 2 over 3. We don't need that. No negative exponents on your answers. Okay? So that is it. You do the same thing on this part. You treat the 2x as it is, guys, the way that you've been treating those 2x before as a single part. So meaning to say we're going to simplify the rest of the question. All right, so it's going to be like this. Let's just have a fraction. Let me go back to the normal mode. So you're going to have a fraction here. These are in the numerator 1 over 2 times negative 1 over 2, negative 1 over 2 times 4 squared. Those ones are in the numerator times 4 squared over 2 factorial. So the factorial of 2 like this is going to give us negative 2. So as we can see, simplifying all these numbers that we are given, we're going to get negative 2 times this 2x to the exponent of negative 3 over 2. This is the one that I'm saying you must take it in the denominator as it is carrying what? A negative exponent. So it will be 2x to the exponent of 3 over 2. You've removed what? The negative exponent. So from our laws of exponents, this is the same as negative 2 over the denominator is 2, so it's going to be a square root. Then we take our 2x as it is to the exponent of what? To the exponent of 3, to the exponent of the numerator. The 2 in the denominator is the one that is here, so we do not write it, guys, for a square root, all right? We must know that 2 is already there inside. So it is in the simplified form. Let's simplify the next. Doing the same thing, this here is a single term. So you evaluate the rest on your calculator. So we're going to have a fraction 1 over 2 times negative 1 over 2. Okay, you're going to multiply to negative 3 over 2 times negative 3 over 2 times the last term there, which is 4 to the exponent of what? Of 3. Everything over 3 factorial, the factorial of 3. So that was going to give us positive 4. So simplifying everything here is going to give us positive 4 times this that we ignored, the 2x to the exponent of negative 5 over 2, which is the one that you must get rid of the negative exponent. How do you get rid of that? It will be over. All right, sorry for that. So it's going to be over that. We said it's 4 over that 2x to the exponent of what? 5 over 2. So it'll be positive 5 over 2. So guys, as we can see, that is the last part that we had. The 2 in the denominator, square root. The 5 is our exponent. So it's 2x to the exponent of what? Of 5. So it was going to be like this. We're going to expand and so on and so on and so on. Those are the terms that we're going to have. For the 4 terms, as we are given our question, it is saying up to 4 terms. So those are the first four terms that you were going to have in simplest form. Okay, anyways, let's check 4.3. We have got a derivative again on 4.3, and that is supposed to be using what? Function of a function, or the chain rule. Okay, so how can we apply our chain rule? Remember that the derivative, when you're dealing with a function of a function, we must introduce a function where there's another function. So there is a function of x. We can introduce another function, which is u. So let u be equal to 2x. So if u is equal to 2x, therefore y is equal to what? Therefore y is equal to 5 sec. In place of 2x, we now have what? We now have a u. So it's 5 sec u, like that. Just like that, guys, use the function of a function formula. The derivative of y with respect to x is the derivative of y with respect to u times the u with respect to what? The derivative of u with respect to x, which you have the formula. So all you just needed was to find these derivatives. The u with respect to x is going to give us 2. All right, that's a linear, guys. Then the y with respect to u, if you differentiate sec, remember sec is going to give us sec tan. So that's 5 sec of u, tan of u, sec tan. So it's going to be sec tan. Then we combine them as given on our formula. Our formula is telling us that we can combine this by what? By multiplying those two derivatives. So meaning to say that was going to be this 5 sec of u times the tan of u times what? The derivative of u with respect to x, which is 2. So combining these together, as we can see, we can multiply the 5 and the 2. That's going to be 10 sec of u times the tan of u, which is not complete because we are talking about the derivative of y with respect to x. But our answer is not having x, it is having u. It is having the u here. So substitute with the u that we decided to use here. We said u is what? Let u be what? Be 2x. So in place of that u, we are going to substitute 2x on that one. So therefore the derivative of y with respect to x is going to be 10. The sec of what? In place of u, we put 2x. Okay, times the tan of u. In place of u, we put 2x. So that is it, using the function of a function for those marks. Just like that, guys. You can see that they repeat them. Revise as many questions as you can. All right, on another question, the derivative of each term with respect to x, as we are given y with respect to x, we must differentiate each and every term. So before you differentiate, just try to rewrite in a way that you can be able to differentiate them properly. Okay, so that was it. Let's see. I'm just gonna write the final answer here. The derivative of y with respect to x. Okay, so let's see. The derivative of y with respect to x is gonna be equal to what? The first part, there is pi over 3 over this x to the exponent of minus 3. So let's take the minus on top. Remember, x to the exponent of negative n is same as x to the exponent of n. So it was going to be y is equal to pi over 3. We take the x up. So it will be x to the exponent of a positive 3. From a negative, it will be a positive there. Then we can differentiate with respect to x. Drop the exponent and subtract 1. So that's it. It's going to be pi over 3 times 3x squared. You subtract 1. This one and this one are going to cancel. So that'll be pi x squared. That's our derivative. In the final place, pi x squared. Okay. We do the same for the next. As we can see, it is taking the same concept. The e is raised to the negative. So let's take it up. So that's y is equal to negative 3p, negative 3p e to the exponent of 4x, where we can properly differentiate with respect to x. Remember, for an exponential function, it remains as it is, but we must multiply our answer by the derivative of f of x, which is drop the 4 here. So it was going to be negative 3p times 4 e to the exponent of what? 4x. Integral, we divide. Derivative, you multiply. So this was going to give us negative 12p e to the exponent of 4x. Okay, so this one is direct and straightforward. We have differentiated our part. We move on to the other one. Plus 1 over this, 1 over cosec. Remember, 1 over cosec, it's a sine. So y is equal to the sine of what? Of 4x. So differentiating y with respect to x, guys, a sine gives us what? A cos. We have it on our formula sheet, but the 4 has to be used there. We multiply by that 4. So that's 4 cos of 4x. Okay. We move on to the other part where there is the ln of x. Remember, the derivative of a ln, guys, is 1 over x. So it's 1 over x, but already there's a constant there, which is this one, minus 1 over pi. So, guys, we are just multiplying constant to constant. So it's minus 1 times 1, which is 1 pi times x. That's pi x. You find the derivative of ln, you multiply it to the constant. 10 to the exponent of 6x. Remember, guys, I've talked about this derivative with respect to x, where we are given a to the exponent of f of x, where we're going to have the derivative of f of x times a to the exponent of f of x times the ln of a. So that is what we have, 10 to the exponent of 6x. Our f of x is 6. So what is its derivative? Just like that. This one was straightforward. We can even just write our answer straightforward. The derivative of f of x, 6x, is 6. Its derivative, a to the exponent of f of x, 10 to the exponent of 6x as it is, times the ln of a. The a is our base. So it is the ln of what? The ln of 10. Just like that. Negative cos 3 pi is a constant, as we do not have x. So it's a constant. Remember, the derivative of a constant gives us what? A 0. So that was going to give us a 0 there. 9tx. It's a linear. So the derivative, we're just going to take that part, the coefficient of x, which is what? Which is 9t. It's a linear. Mx, 2x, 3x. The derivative, we just take these coefficients, 3, 2, like that. We have differentiated each and every part. Each and every part. So that is the derivative concept. You must differentiate each. So you simplify before differentiating. With this, you can obtain the full marks. They just mark the final answer, guys. So even if you can just look into the question and tell to say the answer is this, and you do that, it's still okay. It's still okay. Okay, the last part of our question, which is question number 5, we are given that sketch the graph of e to the exponent of x, e to the exponent of minus x. These are exponential graphs, guys. That is the basics of our exponential graph, guys. So here I'm not gonna talk much to say the graph of e is like this, guys. We know that if it is e to the exponent of x this way to the exponent of negative x, okay, we have, did I post, maybe I did not post that video, but I have done that one about exponential graph. Maybe I'm just gonna need to find time, upload it, and so on, so that we check for those who want the basics. So this graph crosses the y-axis at 1, where x is equal to 0. And when it is a negative, it will be in this side and tending to reach the x-axis, just like the previous case. It will be like that one, okay? So that is for y is equal to e to the exponent of negative x, passing through 1 as the y-intercept, and the x-axis as the asymptote. It cannot cross the x-axis. But they did not end there. After these two graphs, they said, and x is equal to 2. Remember, the line of x is equal to 2 is the vertical line. From the y-axis, we know this is x is equal to 0. So x is equal to 2. Let's say this is 1, this is 2. It's a vertical line that we're going to have. All right, so that is x is equal to 2. Y is equal to, those are the horizontal lines, okay? So that is the area bounded by these three graphs is going to be this part, guys. This is the part that is bounded. So on the part that is bounded, we can see that the limits are for x, because here, where there's a intersection of the graphs, if we go down, we can see that the value of x is there. That's a 0. There also we've got the x is equal to 2. So our limits are for x. Therefore, the representative strip must be for what? Must be for x. We are going to have the representative strip for x. Okay? So that is the sketch and the representative strip. Then 5.12, what they need is for you to calculate the area indicated between two functions by means of integration. So if it is between two graphs, we can use our integration just like when it is on a single graph. All right. Remember, the area is the integral of y with respect to x from a to b. Because there are two graphs, the y part, we must subtract those two graphs, the one on top minus the one on the bottom. So the one on top, we're going to call it y1. The one in the bottom, we're going to call it y2. So it's just going to be y1 minus y2, top minus bottom, with respect to x. So that is y1, the one on top, this one. This is the one on top, e to the exponent of x, minus the one below, which is this one. In between where the area is, we can see this is the one that is below. So it is this one. This is the graph that is here below. So that is our e to the exponent of minus x. We can integrate this with respect to x. Our limits from where these graphs are in between is the 0 and the 2. The limits for x, 0 and 2. Remember, I talked about that. So that is it. Our area can be calculated. Integrating x, e to the exponent of x, it is e to the exponent of f of x over the derivative of f of x. So it was e to the exponent of x over the derivative of x is what? It's 1. So guys, there's no effect. It's just going to remain as e to the exponent of x. But the next one, if we take that, it was going to be minus e to the exponent of minus x over the derivative of that, which is what? Negative 1. So negative, negative cancels. So that will end up as a positive here. So that's positive e to the exponent of minus x. So take note, guys, over the derivative of that, it's going to be negative over negative. Okay, our limits from 0 to 2. We can find the exact solution by substituting our limits upper minus the lower limit. In place of x, our upper limit is 2. So e to the exponent of 2 plus e to the exponent of minus 2. We subtract when our x is 0 as our lower limit in place of x. So that's e to the exponent of 0 plus e to the exponent of 0, guys. There's nothing like minus 0, guys, okay? So that is it. We can just use our calculator straightforward. Yes, we can simplify the first part and see what you are obtaining, or just use your calculator, open bracket, shift, that's e to the exponent of 2 plus e to the exponent of minus 2. Okay, let's close this bracket. Minus, guys, any number to the exponent of 1, I mean to the exponent of 0 like this is 1. So it's just like 1 plus 1, which is what? Which is 2. 1 plus 1, that's 2. So that was going to give us 5, comma this. We can even fix it to 3 decimal place. 5, comma 524. 5,524. That is area. Area in square units. You're dealing with what? Area. We are done. Integration can be used to determine area. Those are the applications. Derivatives for what? For turning points, point of inflection. Those you can apply derivatives. But for area, integration is the application. So that was it on 5.1. 5.2, evaluate this integral. It is just integrating, then substitute the limits. That was a direct question again. The integral, okay, there are no limits. Where am I getting the limits? There are just no limits, actually. It's just integrate. All right, the integral of a to the exponent of f of x with respect to x can be given as a to the exponent of f of x over derivative of f of x times the ln of a. We can integrate that. So that is our a, and this is our f of x, guys. So that was going to be 5, our a to the exponent of what? F of x, 5 to the exponent of 2x over what? The first derivative. Our f of x, guys, is 2x. So what is its derivative? What is its derivative? That is 2. This is the one that we need here. Times the ln of a. Our a is what? 5, the base. Just like that. Just like that. But there were limits, man. There were limits. Let me check. Because I remember here, it is because of when I put this one on the board, guys, it removes some of the other things that it does not notice properly. So here I can see. So like I said, you can download the question paper on the description of the video, or if you check on the comments of the video, I'm gonna put it there. So on the actual question, guys, there were limits there. I'm checking this. Let me check the question paper. There were limits here from 0 to 2, because I was remembering that on my preparation I had as limit somewhere. Now I don't see it. So there's a limit there. Use your question paper. You're gonna see that there are limits. Just to hope on the question paper, guys, it's not the one that I removed this. Maybe it's not there also, but I'm gonna next time I'm just gonna use the one that I download as it is, guys. I'm just gonna put it there on the drive. So also for question papers, guys, you can check the mathematics N4, the whole of it, like the drive for mathematics N4. If you check the description of the channel, there you can get all the question papers that I have and use them for revision. If there's something that you do not understand, you are part of membership, you can ask questions from there. So anyways, guys, here there were limits, so let us put our limits here. It is 0 to 2. So upper limit being 2. So I'm just going to put 2 here. So 2 times 2, that's 4. So 5 to the exponent of 4 over 2 ln 5 minus to the exponent of 0, guys. Any number to the exponent of 0 is what? It's 1. So that's 1 over 2 ln 5 like this. So I can just simplify this straightforward from our calculator. 5 to the exponent of 4 over 2 ln 5. over 2 ln 5 like this. Okay, then we subtract 1 over 2 ln 5. So this is what you're going to get. So it was going to give us 193,856 3 decimal places. 193,856. Okay, so that is what we had on this question. Sorry for that. We just need to consider those limits. They are part of our question. Okay, that is it. 5.3 integrate. Okay, let me check if there's anything that happened on our question. Nothing. Okay, so yeah, it's fine. Okay, so we're given to integrate this. Okay, and we had with respect to alpha. And if we check properly, we can see the numerator, that's a difference of two squares. 5 is a perfect square, 4 is a perfect square. So remember, a squared minus b squared is a minus b into a plus b. So this is same as 25. 5 is squared, sec squared alpha minus 2 squared. So as you can see, guys, it's a difference of two squares. So you're going to have 5 sec of alpha minus 2. The other bracket, it adds these two. We're going to add 5. The sec of alpha plus what? Plus 2. Everything over our denominator, which is in a simplest form. There's nothing that I'm going to do on this one. So that is it with respect to alpha. The brackets here are the same. Let's cancel these. So we are left with this part. Okay, so let's rewrite and see the integral of what? 5 sec of what? Of alpha plus 2. With respect to that alpha, we can integrate. Remember, if you integrate sec, it is there from your formula sheet. It's gonna give you ln sec of x plus tan of x. You have it in your formula sheet. So our x is alpha, guys. So that was going to give 5. It's a constant, so it's gonna be 5. The ln of what? Sec of what? Sec of alpha plus the tan of what? The tan of alpha, like that. So that is what you're going to have. Then if you integrate 2 with respect to alpha, it is just like integrating 2 with respect to x. It will be 2x. So this will be 2 alpha plus what? The constant of integration. So that was it. That was it. You're done. You integrated each part. Integrated each part. There are no limits for this one. There were no limits that you're gonna put or substitute there. So you are done. Then 5.4, integrate this, the whole part. So just like that part of our derivatives, also they give us for the integrals where you need to integrate each part. Okay, so let's see what you're gonna have here. 3 over cosec. Remember, cosec, 1 over cosec, it's a sine, so it's gonna be the sine of 3x. So if we integrate the sine from our formula sheet, sine gives us a cos. But remember, we must divide by the what? This 3. So it's 3, negative 3 cos of 3x, then divide by that 3. So this was going to cancel and get negative cos. So it was going to give us negative cos 3x. Okay. We move on to the other part. Negative 7, this one is from our exponents part. It's a direct integral, guys. Remember I talked about that integral ka to the exponent. If there is a constant, just also consider the constant on your solution. A to the exponent of f of x, the first derivative times the ln of a. So that's gonna remain as it is, this one. So it was gonna be negative what? Negative, as it is the numerator, guys, 7 times 2 to the exponent of 3x over what? The derivative f of x. The derivative of 3x is what? Is 3 times the ln of a. Our a is the base, which is what? The ln of 2. Okay, we are done. We move on. 2 pi. When dealing with e, you are differentiating. Remember, it is that e over the first derivative. So it was going to be 2 pi. All right, it was going to be 2 pi e to the exponent of 2x over the derivative of this, which is 2. So this was going to cancel. So at the end, we've got pi e to the exponent of 2x over what? Okay, there's no over here. There's nothing that you're going to divide. Okay, it canceled. Remember the 2 and the 2. Then the 10 to the exponent of negative 2x, it is the same as this one. So it was going to remain as it is in the numerator, 10 to the exponent of negative 2x. Then we find the derivative of that f of x, which is negative 2 times the ln of the base. Our base is 10. So that's it. So that's going to be negative 10 to the exponent of negative 10x, negative 2x there over 2, the ln of 10. So that is it. There, we are just given this as it is, and there is no x. So remember, if you integrate a constant, guys, you do not have x. You're just going to put x on your answer, okay? It's just like the integral of a with respect to x. It will be ax. So here there is no x. We do not have x on this whole part. So it's a constant. So you're just going to take that constant, multiply it by what? By x. 3 pi over 6p times x. Then cosec cot, it's a reverse from our derivative from the cot. But remember, I mean, when you differentiate a cosec, but it gives us a negative. So it was supposed to be negative cosec of x. That is what you're supposed to have here, negative cosec of x. But because of the negative also on our question here, negative will be what? A positive. So it will end up as a positive. So this is what we have. It's integration. So after integrating each and every term, do not forget the constant of what? Integration. So we have integrated each and every part for 7 marks. Okay, they're gonna give you 7 marks for this. So those are the typical questions, guys, that you must expect. You see that it is a repetition, guys. We just expect new questions or formality. The formality is the same. I will just give you maybe 1 or 2 things. Just you need to simplify, figure out that. So for mathematics N4, guys, I expect you guys to totalize these question papers. Even your final exam, you must totalize this. It's one of the easiest that you can actually totalize because it's straightforward. Yeah, we are going to do maths, guys. Later on, we are coming to N6. That is where we'll be doing maths. For now, let us play around with our N4, know the basics, revise even your grade 12 mathematics, grade 11 mathematics. Do all those just to gather information that you'll use later on in your N6 mathematics. Okay, guys, so that was it for our question paper. Like I said, we must be able to totalize such exams. So we shall see the next exams that we have. That is all the best, guys, as we are preparing ourselves for these exams, which are ahead of time. Give yourself time, okay? Understand all the basics. If it is possible, join the membership so that you'll be able to access other classes which we have that is for those introductions, activities also. And if you have got questions where we've got time, I'm gonna go through that one and bring it back to your platform. And also utilizing the community section. If you check on our YouTube, on you have got the community part, that community section. Use that community section to ask your questions, upload even the questions that you need assistance in, especially if you're under part of membership, because we're going to look into that. But because of so many requests, guys, also as an individual, just give us time, guys, to work on your areas that you need clarification, so that when we bring those activities or introductions, you have got all the necessary information that you need to prepare for the what? For the exams. So that is it, guys, from Maison African Motives. Till we meet again.